Okay. Assalamu alaikum, everyone. We are starting October number 2024, A-level chemistry 9701, paper 42. Let's start with question number 1. The equation for the reaction 1 is shown. Reaction 1 is first order with respect to the concentration of X. The half-life of the reaction is 900 seconds at 20 degrees Celsius. Okay. A solution of X with a concentration of 0.12 mole per dm cube is prepared at 20 degrees Celsius. Calculate the average rate of reaction over the first 1800 seconds. Okay. So what they have provided you few things that they have given you the half-life. They have given you the concentration, and they are asking you that if there are 1800 seconds, then what is the average rate in 1800 seconds? So if you see how many half-lives 1800 second may have, two. So it means this concentration is going to get half, which means if I half it, it is going to be 0.09 after first half-life, isn't it? And then after second half-life, it is going to be further halved, which means 0.045. Is this understandable to all of you? So it means that the total change in concentration in 1800 second is going to be 0.09 plus 0.045. So it is going to be 0.135 moles per dm cube. So that is the change in concentration in 1800 seconds. Is this understandable to all of you? Okay, I am repeating. Let's see. They are saying that 900 seconds is the half-life. So it means in 900 seconds, the concentration is going to be half of the initial concentration, isn't it? So is this clear? So if the initial concentration is 0.180, so after 900 seconds, half of it is going to be used up. So it means this much amount is going to be used up, right? Is this clear? Now this is the initial concentration for the next half-life. And after the next half-life, this much amount is going to be used up, isn't it? So this is going to be this much amount of the X is going to be used up in the first 900 seconds, and this much amount of the X is going to be used up in the second half 900 seconds. So the total amount which is decreased or which is used up is this much in 1800 seconds. Is this clear? So we know the concentration, we know the time. So average rate is always the change in concentration divided by time. So the change in concentration is 0.135 divided by the time, which is 1800 seconds. Yes, can anyone tell me the answer, please? Okay, Shahid, thank you so much. So it is going to be 7.5 exponent minus 5 mole per dm cube per second. Now, complete the rate equation for reaction 1. So as they have told you that it is the first order with respect to reactant X. So rate is equals to rate constant K times concentration of X. It's easy. Show that the rate constant K is 7.70 exponent minus 4 second inverse at 20 degrees Celsius. So see, the overall order of a reaction is first order. So for this case, we are going to use this expression that T half is equals to 0.693 over K, or you can move it that K is equals to 0.693 over half-life. So 0.693 divided by 900. Yeah. So you will get the answer. Can anyone tell me the value? This is the rate. This is the expression that you need to remember, Amna. Okay. Over here, we are getting 7.7 exponent minus 4. Okay. And remember, this expression is used for the reactions who have overall order first. Okay. Is this clear, Amna? Calculate the initial rate of reaction 1 when the concentration of X is 0.15 mole per dm cube, include units. Okay. So they have given you the concentration. You have the rate. Rate is equals to K, concentration of X. We know the value of K, which is 7.7 exponent minus 4 times concentration of X is 0.15, 0 mole per dm cube. So just multiply it as 1.16 exponent minus 4, and the unit is going to be mole per dm cube per second. Yeah, Dua, 1.155 exponent minus 4 is also correct, but when I'm going to write it in three significant figures, it is going to be 1.16. So do remember, everyone, at least your answer in three significant figures, not lesser than that. Okay. Now, next part. Catalyst may be homogeneous or heterogeneous. Platinum is a transition element. Explain why transition element behaves as a catalyst. So one reason that they have a variable oxidation state, so they can interchange into these, right? Very good, Shaheen. So one reason is having a variable oxidation state. And when they turn into one species and they turn back into another species, so that's how they are doing by accepting the pair of electron or by making a dative bond. And it happens as they have a empty d orbitals. So empty d orbitals so can accept pair of electrons. Next part. Name the metal catalyst in Haber process and explain why it is heterogeneous catalyst. So if you recall, it is a iron, and further, nickel is not used in Haber process, Shazil, and different state or different phase as compared to reactants. Now, platinum acts as a heterogeneous catalyst in the removal of nitrogen dioxide from the exhaust gases of car engine. Describe the mode of action of platinum catalyst in this process. So if you remember the heterogeneous catalyst, their mode of action is very easy. There are three things: adsorption on the surface occur, then reaction occurs, reactant turns into products, bonds of the reactants gets weaker, and then the product gets dissolved. So first thing, adsorption. Second, bonds of reactants gets weaker in order to make product. And when the product is formed, that dissolved. Okay. Now part 4. NO2 act as a homogeneous catalyst. Okay. In the oxidation of atmospheric sulfur dioxide, write equation for the two reactions that occur. So if you recall, when NO2 reacts with SO2, it turns into NO by giving its oxygen to sulfur trioxide. As soon as NO forms, it is highly reactive. It reacts with oxygen to form NO2 again. So you have to balance the equation. Do remember that you need to balance the equation, okay? One minute, please. Okay. Now see part. SO2 dissolves in water to form sulfurous acid H2SO4, H2SO3. H2SO3 oxidizes under acidic conditions. The relevant electrode reaction. And its E naught values are shown. Okay. So that is the reverse reaction shows the oxidation of H2SO3, right? 4 more half equations for the reaction occurring under acidic conditions and their E naught values are shown. Okay. Select the oxidizing agent that could oxidize H2SO3 to SO4 to negative under acidic condition. So the oxidizing agent means which undergo reduction itself. And for that, its E naught value must be higher. Write an equation, give the E naught cell value for the reaction at that time. So it's positive 1.77, positive 0.17. So this, and this are not going to be used. Only this one is going to be used. Yes, Shahid, very good. So the oxidizing agent is going to be this one. So oxidizing agent is going to be BiO positive. Okay. It has a 3 electrons and it has a 2 electron. So first thing that this equation is going to be flipped. Secondly, this equation is going to be times 3. This equation is going to be times 2 in order to make the balance the electrons. So if I start with the first equation, I need to flip that equation as well. So 3 moles of H2SO3 with 3 moles of H2O and 2 moles of sulfate. No, not 2. 6 moles of sulfate, 12 moles of hydrogen ions, and 6 electrons. And this equation, 2 moles of BiO positive plus 4 moles of hydrogen plus 6 electrons plus 2 moles of bismuth plus 2 moles of water. Now when I'm going to add the two equations, the electrons are going to be cancelled out. 2 waters, 1 water left over here, all 4 hydrogen, and over here we are left with 8 hydrogens. So the equation would be, in that equation, 3 moles of H2SO3 plus 2 moles of BiO positive plus water. And in the net equation, you only make a one direction arrow on the right side only. 6 moles of sulfate, 2 moles of bismuth, and 8 moles of hydrogen ions. Now, E naught cell is always E reduction minus E oxidation. Reduction has always a greater value, so the reduction is positive 0.28. Oxidation is positive 0.17. You need to subtract them. So 1, 1. So positive 0.11 volts. Is this clear to all of you? Now, question number 2. Predict and explain the variation in enthalpy change of hydration for the ions sodium, magnesium, and aluminium. Okay. So all of them are in the same period, right? In period 3, you will find sodium, then you will find magnesium, then you will find aluminium. So if you see, that is what going to happen, that their size decreases, right? Because of a higher nuclear charge. So from sodium to magnesium to aluminium, enthalpy of hydration is going to be increased, or you can say more exothermic, because the ionic radii decreases, right? Yes, very good, Shahid. And the reason behind this is that forces of attraction with water gets stronger. The more charge density any ion has, it is going to form a bond or attraction more stronger. So more energy is going to be released. Next, D. Figure 2.1 shows an incomplete energy cycle. Okay. Complete line C on figure 2.1 include state symbols. So there is a solid, there are gas. So it means over here we have a magnesium 2 positive in the aqueous and 2 chloride ions in the aqueous. Now, use both words and symbols to identify the change to in figure 2.1. So in figure 2.1, we can write by looking at these, that enthalpy change of hydration of magnesium ions and chloride ions. And now with the symbol delta H naught. No, they haven't mentioned the standard. Mg2 positive and twice of because there are two chlorides, right? So enthalpy change of hydration of chloride. Now what they are saying, use change 1 and 3 as examples how this. Okay, yeah, so we have used this. We are done with part 2. Now, next part. Calculate a value for the lattice energy for magnesium chloride by selecting using appropriate data from the table 2.1. So what we are given with, we are given with the formation, we are given with the solution, we are given with the first ionization. Okay. Just 1 minute, please. Okay. So see, you are given with the solution, you are given with the hydrations. So that is easier. If you recall, we derived one expression that sum of enthalpy change of hydration is equals to lattice energy plus enthalpy change of solution. So we are going to use the solution, dehydration of magnesium and dehydration of chloride. But as magnesium chloride has 2 chloride, so this equation is going to be times 2. So lattice energy is equals to sum of hydration. So we have a hydration of magnesium, 1920, plus twice of the hydration of chloride. And then we have to subtract the enthalpy change of solution. So minus 155. Can anyone solve it and tell me the answer? Thank you, Shahid. So it's minus 2493 kilojoules per mole. Is this clear? Now, define entropy. So if you recall the number of arrangement of particles or energy in the system or the randomness or the degree of disorderness in the system is entropy. I'm not going to write the definitions, okay? Now, next part. At 25 degrees Celsius, the enthalpy change of solution of a compound Z is positive 26 kilojoules. Okay. It is enthalpy change of solution. The entropy change of solution. Okay, so that is entropy change. Calculate the value of Gibbs free energy at 25 degrees Celsius. So Gibbs free energy is delta H minus T delta S. So delta H is positive 26 minus temperature is 25. So 25 plus 27, it's in Celsius, we need it in Kelvin. So 298, right? So minus 298 Kelvin times entropy change is 52 joules, right? See, it's joule, and we need to convert it into kilojoules. So I'm going to divide it with 1000. Can anyone solve and tell me the answer, please? It's positive 10.5. Yeah, positive value means not soluble. Good, Shahid. Use your answer to D to predict whether or not Z is soluble in water at 25 degrees Celsius. Explain your answer. So we have discussed that if the Gibbs free G energy is positive, then the reaction is not feasible. The process is not feasible. So they are talking about the being dissolving a Z. So it means it is not going to be soluble at not soluble at 25 degrees Celsius, as change in Gibbs free energy is positive. Is this clear? Now, last part, predict whether Z becomes more or less soluble as water is heated from 25 degrees Celsius to 95 degrees Celsius. Okay, so if we do so, C delta H minus T delta S. So what you are going to do, C, instead of 298, this value is going to be raised. If this value is going to be raised, okay, you can do this. If this value is going to be raised, then this whole thing is going to be more negative, and as a result, you will get the answer in the negative, right? So delta G will become negative, or it decreases. So as a result, the solution, it becomes more soluble. Yes, very good, Shazid. Very good, Shahid. Okay, so more soluble minus T delta S would become more negative, right? At 95 degrees Celsius, as negative T delta S gets more negative and delta G decreases. So when it decreases, so it makes the solution more soluble. Okay. Now, question number 3. The pH of a saturated solution of calcium hydroxide is 12.35 at 298 Kelvin. Show that the concentration of hydroxide ion in a saturated solution of calcium hydroxide is 0.224 mole per dm cube at 298 Kelvin. Okay. So what you can do, you can calculate the POH from pH, right? Because POH is equals to 14 minus 12.35. Can anyone solve it and tell me the value of POH? 65. Is it 1.65? Right? It's 1.65. So from POH, can I calculate the concentration of hydroxide ion? Concentration of hydroxide ion is going to be 10 raised to the power minus POH. So minus 1.65. Can anyone tell me the value? Okay. So we are getting 0.0224 mole per dm cube, and that's what they ask you to justify. So we have justified. Okay. Now use the data in given in 1. Calculate the solubility product KSP for calcium hydroxide at 298 Kelvin. Okay. So calcium hydroxide dissolves to give you 1 mole of calcium ion and 2 moles of hydroxide ions, right? So this is the concentration of hydroxide ions. So the concentration of calcium ion is going to be half of this one. So it is going to be 0.0224 over 2, which is going to be 0.0112 mole per dm cube. Is this understandable? And now the KSP expression is equals to concentration of calcium ions times square of the concentration of hydroxide ions. So it is going to be 0.0112 times square of 0.0224. So the unit is going to be mole cube dm minus 9. Can anyone calculate the value and tell me the answer, please? Okay, thank you. Raheel. It is going to be 5.62 exponent minus 6. Thank you, Shazad. Next, a spatula measures of solid calcium chloride is stirred into a sample of saturated calcium hydroxide solution. All of the calcium chloride dissolves. Describe one other observation that would made and give an estimated value of the pH of the solution obtained. Explain both your answer. So yes, what will be the other observation? Because if you recall, calcium hydroxide is relatively less soluble. So if it is relatively less soluble, so it is going to be precipitate out. So what we are going to see, we are going to observe white precipitates or white solid being formed as the calcium chloride dissolves. But it doesn't, it means, well, we are actually not sure that all of the calcium hydroxide is precipitated out or not. So there is a might chance that some of the hydroxide ions left behind. So the pH would be around 8 or 7.5. It's slightly alkaline. So that's how we predict the pH. The explanation. So the explanation is the calcium ion causes common ion effect because it's a calcium hydroxide is already there and you are adding calcium ion in it, right? So causes common ion effect. Hence, calcium hydroxide precipitated out. Now, fourth part. Calcium hydroxide reacts with dilute sulfuric acid to form calcium sulfate. Barium hydroxide behave in a similar way, forming barium sulfate. Explain why calcium sulfate is more soluble than barium sulfate. So it's the reasoning is exactly opposite of the solubilities of hydroxide, right? So from calcium to barium, because barium is below, calcium, strontium, and then barium. And we are going to compare these two, right? Both lattice energy and enthalpy change of hydration gets less exothermic, right? But in case of sulfates, change in enthalpy change of hydration is greater than the change in lattice energy. As a result, enthalpy change of solution gets more endothermic or less exothermic. So as it gets more endothermic, so as a result, barium hydroxide gets less soluble. Is this clear to all of you? Okay. Now, next part. Just 1 minute. Yeah. Some solid calcium is added to excess of aqueous ethanoic acid and left until all the calcium has reacted. The resulting mixture D, contains no undissolved solid. Okay. Write an equation for the reaction of calcium with ethanoic acid. So when a metal and a acid reacts, we will get salt and water, right? So we will salt and hydrogen gas. So we get a hydrogen gas. Ethanoic acid has a charge of -1, calcium has a charge of 2 positive. So it is going to be CH3COO twice Ca. To balance the equation, I need to put 2 over here. I hope it's clear to all of you. Yeah, that can be done as well, Shazil. Now use formula of a molecules and ions to identify two conjugate acid-base pair present in the mixture D. Here one should consist of organic species. So the conjugate acid is CH3COOH and its base is going to be CH3COO negative. So other than this, the acid, because it's aqueous solution, so the acid is hydronium ion H3O positive and its conjugate base is going to be water. Now, they are asking to write the equation K expression. So when you dissociate weak acid, it dissociates reversibly to form the ethanoate ions and the hydrogen ions. So the Ka expression would be the concentration of ethanoate ions times concentration of hydrogen ions over concentration of ethanoic acid. Right? Now, the concentration of calcium ethanoate in mixture D is 0.394 mole per dm cube. The concentration of ethanoic acid in mixture D is 0.27 mole per dm cube. Calculate the Ka of ethanoic acid, oh, the Ka, the pH of mixture D. So if you see, mixture D is a buffer solution, isn't it? Because it has a weak acid and its salt both. If you see, they give you the concentration of calcium ethanoate, not just for ethanoate ion. So if you go for the concentration of ethanoate, so because it has a 2 ethanoate ions, so the concentration of ethanoate ion is going to be twice of 0.394. Can anyone calculate it? And the concentration of ethanoic acid that is provided to you is 0.270, right? So times 2, 8. So is it 0.788, right? Mole per dm cube. So now you are going to use the expression for the buffer pH is equals to pKa. So pKa is minus log 10 Ka, 1.74 exponent minus 5 plus log 10 salt over acid. So salt is 0.788 over 0.270. Can anyone calculate it and tell me the answer, please? Okay, Shahid, thank you. So the pH is 5.22. Write two equations to show how mixture D can act as a buffer solution. So one you are going to use by adding acid. So acid is a hydrogen ion. So the conjugate base of a buffer, which is CH3COO negative, use up this hydrogen ions to control the pH. No excess hydrogen ions are there. So no increase in pH or decrease in pH. And when we add alkali, there are lots of hydroxide ions. So with hydroxide ion, the weak acid undergoes reaction losing its hydrogen turning into conjugate base, and the hydrogen neutralizes the hydroxide, and from the alkali giving you water. I hope it's clear to all of you. Okay. Now, question number 4. The transition metal atoms and transition metal ions form complexes by combining with a species called ligands. Okay. When sodium hydroxide aqueous is added to an aqueous solution of containing hexa-aqua cobalt 2 ions, a precipitation reaction occurs accompanied by a color change. In this reaction, two of the water ligand each loses a hydrogen ion. The hydrogen ions are gained by the hydroxide ions from the NaOH. State the color change from this precipitation reaction. So if you recall, the color of the cobalt is initially, yes, it's pink. Very good. Fatma, very good, Shazel. And it changes to blue. The precipitate formed are of blue color. The copper in this, the same reaction occur with the copper, and copper also forms a light blue precipitate, and cobalt also forms a blue precipitates. Okay. Now, complete the ionic equation for this precipitation reaction. So for the ionic equation, you are going to put two hydroxide ions. Then over here, you are going to put COOH twice, H2O4. Now no charge because two hydroxide ions. And over here, you will be getting two water. This precipitation reaction can also be described as a different type of reaction. Name this type of reaction. So if you see, as the hint is there, the two of the water ligand each loses hydrogen ion. So it means it is behaving as an acid, right? So it's an acid-base reaction. Remember, acid-base reaction is not a redox reaction. There is no change in the oxidation number of any element. The oxidation number of a whole compound is changed because the ions were there have a different oxidation number, but any element is not changing its oxidation number. So it's acid base. Now, B. L is an uncharged tridentate ligand. L donates 3 lone pairs to a metal atom or ion. Cobalt forms an octahedral complex ion E with L. Complex ion E has a +2 charge. Give the formula of E. Okay. E is going to be cobalt L3 with 3 positive charge. No, my bad. It is going to be L2 because L is a tridentate ligand, right? So one L ligand is going to form 3 dated bonds. So the 2 L ligands are going to form 6 dated bonds. So octahedral. Identify the oxidation state of cobalt in this. So cobalt has oxidation state of 3 positive. No, the complex E has a +2 charge, right? Okay. So, and we see that L is uncharged, right? So the +2 charge is due to the cobalt. So the oxidation number of cobalt is +2. Yes, very good, Shahi. Now, the d orbitals of the cobalt atom or ion present in E are split in energy. State the number of d orbitals that are at a higher energy level and the number of d orbitals at a lower energy. So these are octahedral. So in octahedral case, the 2 set of d orbitals goes to the higher energy and 3 set of d orbitals goes to the lower energy. Yes, very good, Shazad. Define the term non-degenerate d orbitals. So the non which have a different energies, yeah. Orbitals with different energies. Now, C part. The mineral chromite contains a compound which has the formula FeCrNO4. The oxidation state of iron is +2. Okay, Fe is 2 plus. The 4.18 gram of FeCrNO4 is dissolved in excess of sulfuric acid. The resulting solution is made up to 250 centimeter cube. Okay, so 4.18 gram is dissolved in 250 centimeter cube. That is solution F, and from F, 25 centimeter cube has been taken out. Okay, and with that we need this much volume and the concentration of KMnO4. 1 mole of MnO4 reacts with 5 moles of Fe2 positive ion. Assume no other oxidation reaction occur. Write an equation for the reaction of Fe2 positive ion with MnO4 negative. So see, if you remember, MnO4 when reacts with any substance, it makes the other substance undergo oxidation and it will reduce to Mn2 positive. So over here its charge is +7 and over here its charge is +2, which means it is gaining 5 electrons. And over here it's +2 and it's +3. So it is losing only 1 electron. So I'm going to put 5 and 5 over here to balance the loss and gain of electron. Is this clear to all of you? And beside this, they have told you the ratio. 1 mole of MnO4 reacts with 5 moles of Fe2 positive. So you know this. Now, 4 oxygen are there. So I'm going to put 4 moles of water and then 8 moles of H positive ion. So that's how the equation is balanced. Now, calculate the number of moles of Fe2 positive ion in 250 centimeter cube of solution F. So we know the moles of magnate. So we can calculate the moles of magnate because we know the concentration and the volume. So the volume is 18.7 divided by 1000 and then multiplied by the concentration, which is 0.02. Can anyone tell me the answer, please? So 18.7 divided by 1000 multiplied 0.02. Yes. Okay. So it's 3.74 exponent minus 4. So these are the moles. Now the ratio is 1:5. So I'm going to multiply it with 5. So we will get the moles of iron. So on multiplying with 5, it is 1.87 exponent minus 4. No, 1.87 exponent minus 3. Calculate the MR of FeCnO4 and use the answer to reduce the value of N. So see, these are the moles in 25 centimeter cube, right? And the solution is 250 centimeter cube. So it means that in 250, we have 1.87 exponent minus 2 moles. And we have a then formula for MR, that MR is equals to mass upon moles. Mass is 4.18, which is over here, divided by 1.87 exponent minus 2. Can anyone solve it and tell me the answer, please? Okay, thank you. So it is 223.5. So we got the MR, 223.5. Now what you are going to do, 223.5. Remove the iron. What is the AR of iron? 55.8 and chromium is 52. 55.8, right? There are one iron, right? So minus 55.8. Then there are four oxygen. So oxygen is 16, so 16 times 4. So it will give you the mass of n number of Cr. Can you subtract them and tell me the answer? One 119.7. So what is the AR of chromium? Yes, can it's 52. So yeah, you divide it with 52, you will get the number of, so okay, it's 2.30, so which makes it 2. Okay, so it's 2. Is it clear till here? Okay. Now question number 5. Nickel ion forms a number of different complex ions, including hexaquanickel 2 and hexaamine nickel 2 and tridiamine nickel 2. The abbreviation EN represents 1, 2 diamine ethane. The numerical value of the two stability constants are given in 5.1. Okay. Complete the expression for K step for any EN3. So I have told you earlier when you have to write the K step for any complex, remember that complex, remember the equation for the for that complex being made from water and then make its Kc expression, so that will be its K step. So it means in the denominator, in the numerator, we are going to have Ni, En3, and its concentration. In the numerator, we are going to have a one nickel hexaqua complex and concentration of En to the power 3. Okay. Now, next one. A solution of hexaqua nickel is added to a solution that contains 0.1 mole per dm cube ammonia and 0.1 mole per dm cube ammonia. Predict which complex this or this is present in the resulting mixture. So it is can be identified by the K step comp value. So if you see its K step is exponent 7, but its K step is exponent 18. So it is more stable. This is more stable. So if it is more stable, so it means it is going to be present in the solution. And the explanation will be very easy, that it has a larger or higher K step value. Is it clear? Okay, now complete the equation for the ligand exchange reaction occurring in 1. So En is being reacted, right? So 3 moles of En. Now over here, Ni, En 2 positive with 6H2. Is this clear? Okay. Now, complete figure 5.1 to show the three-dimensional structure of the two stereoisomers. Okay, so these are, if you recall, optic practical isomerism, right? The type of isomerism is optical isomerism. And over here, you are going to draw the two mirror images. Like this. So that's how you can make the two mirror images. Fatma, see over here, it is provided that nickel En complex has a greater value exponent 18, right? Okay. Now, question number 6. Figure 6.1 shows two reactions of ethane dioic acid. Okay. If you recall with the SOCl2, if I'm not sure, yeah, if I'm not wrong, we are getting this. Both the OH are displaced by chlorine. And C, this is turning into carbon dioxide, so it means it's an oxidation. And ethane dioic acid is oxidized by acidified magnate or dichromate, heat under reflux, HUR. Okay, draw the organic product G in the box. So we have already done so. Okay. In figure 6.1, SOCl2 is given as the reagent that reacts with ethane dioic acid to produce G. Identify the different reagent that also reacts with ethane dioic acid to produce G. So to produce G, yes, very good, Shazil. We can use PCl5 or we can use SOCl2 as well. No, okay, SOCl2 is given, sorry, PCl3 as well. So you can write anyone, okay? Identify two reagents that oxidizes ethane dioic acid to form carbon dioxide and water. Two different reagents. So one is acidified potassium magnate. Second is acidified dichromate. Ethane dioic acid ionizes as shown. Okay. Is much stronger acid than methanoic acid. Suggest an explanation for this difference in acidity. So the thing is that it has a 2C double bond O, right? And methanoic acid has a only 1C double bond O. So the carbonyl groups are electron withdrawing and in ethane dioic acid, 2C double bond O groups makes OH bond even more weaker. Is this clear? Yeah, or you can write it stabilizes the anion. Now D part. Just give me a minute. Benzene 1,4 dicarboxylic acid. Okay, here you go. Can be made from benzene in two steps as shown in figure 6.2. So this is the identity of J by triangle structure in the box. So yes, very good, Shazil. Very good, Arish. So over here we have a benzene ring. And if we get the two methyl groups, so these two can be oxidized in step 2, right? Yes, very good, Shazil. Identify the reagents and conditions for step 1 and step 2. So for step 1, as CH3 is being added to a benzene ring, so CH3Cl along with AlCl3. And in the second case, we need hot alkaline potassium magnate, and then we use hydrochloric acid secondly to. No, not acidified KMNO4. Benzene, side chain on benzene can always oxidize by alkaline KMNO4, then we add acid. Draw the structure of exactly one repeat unit of the polymer formed when benzene 1,4 dicarboxylic acid reacts with ethane 1,2 diol. The linkage between the monomers should be shown fully displayed. So see, it's a dicarboxylic acid, right? Having a benzene ring. So it is going to be 1,4 dicarboxylic acid, right? This one. So from, we know that OH is removed, and from alcohol, this H is lost. So then the carbonyl-carbon bonds with the O, then CH2, then CH2, then O, and then empty bond. So this is how you can make the one repeat unit. Is this clear? Now, fourth part. State the type of polymerization that occur when benzene 1,4 dicarboxylic acid reacts with ethane 1,2 diol and name the linkage found between the monomers. So the type of polymerization is, yes, very good, Shazil. Condensation, and linkage is astrolin. I hope it's clear to all of you. Now question number 7. Benzene reacts with chlorine gas to form chlorobenzene. The reaction can be described as the reaction between benzene molecules and chlorine positive ion. The chlorine positive ions are formed by adding suitable catalyst to a chlorine gas. Give the name or formula of the catalyst that can be used for this reaction. So you can use AlCl3, right? Yes, very good, Shazam. The mechanism for this reaction is shown. The movement of a pair of electrons is presented by X in diagram 1. State whether this pair is of electron is state where this pair of electron is before step 1 takes place. So if you recall, before step 1, it is delocalized in the benzene ring, right? This is the part of the delocalized pi ring. State this pair of electron where this after when step 1 has taken place. So now the arrow is pointing towards, so between carbon and chlorine, CCl bond. Now, the movement of another pair of electrons is represented by Y in diagram 2. State where this pair of electrons is before step 2 takes place. So before step 2 takes place, it is between carbon and hydrogen. State where this pair of electrons is after step 2 has been taken place. So again, delocalized pi system. So it comes, the delocalized pi system is restored, right? Now, there are 6 carbon atoms in diagram 2. State how many of these carbon atoms are sp hybridized, sp2 hybridized, and sp3 hybridized. They are talking about diagram 2. So this one is sp3 hybridized, and 1, 2, 3, 4, 5. Yeah, 5 are sp2 hybridized. Very good, Arish. So sp is 0, 5 sp2, and 1 sp3. No pi bond, sp3, 1 pi bond, sp2, 2 pi bonds, sp. I hope it's clear to all of you. Now, complete the equation for the reaction between benzene and chlorine. So it's very easy. Cl2, C6H5Cl plus HCl. The mechanism for this reaction is electrophilic substitution. Complete the following sentence. Write the formula in the gaps provided. During the reaction, the electrophile is Cl positive and a hydrogen atom in a benzene is substituted by a chlorine atom. Now, F part. Chloroethane reacts with aqueous NaOH. Chlorobenzene does not. Okay. Name the mechanism for the reaction that chloroethane undergoes with NaOH aqueous. Identify the major organic product that is formed. So it's a nucleophilic substitution, right? And it's a chloroethane. So when chlorine displaces or displaced by aqueous NaOH, so OH displaces, so 2 carbon containing alcohol, which means ethanol, is the product. Explain the difference in reactivity of chloroethane and chlorobenzene when treated with NaOH. So in chlorobenzene, AR means aromatic, it represents the, or it's better, okay. In chlorobenzene, the lone pair of, just give me a minute. So in chlorobenzene, the lone pair of chlorine is overlapped with pi ring. So carbon chlorine bonds get stronger. So that's why it does not react. Is this clear to all of you? Yes, Shazil, what you want to say, I don't understand. Now, question number 8. The amino acid serine, you have a formula. Exists in 2 optically active forms. These optical isomers, isomer P and isomer Q, are shown in figure 8.1. Okay. Isomer P and isomer Q have identical physical and chemical properties with the exception of 2 specific properties. One of these properties is their differing effect on plane polarized light. State the other property by which they differ. So if you recall, it's their medicinal activity, biological activity. One is going to ease in the pain and the other one is going to cause the side effects, right? A solution of pure isomer P of a particular concentration rotate a plane polarized light by 5 degrees in a clockwise direction. Describe how a solution of pure isomer Q of the same concentration affects the plane polarized light. So it is going to rotate 5 degrees in anti-clockwise direction because both the isomers are repeat the same value but in the opposite direction. Is this clear? Now, state another term in addition to stereoisomers, optical isomers, non-superimposable mirror images, which can be used to describe the pair of chiral compounds isomer P and Q. Isomer Q. So if you don't remember, these are called enantiomers. Give the term used to describe a mixture containing equal amounts of both the isomer P and Q as they are non-superimposable mirror images. These are optical isomers. Yes, very good, Arish. Very good, Shazil. If they have an equal amount in the solution, that solution is called racemic mixture. Now, describe one way in which a single pure optical isomer of serine can be produced instead of making a mixture of isomer P and isomer Q. So there are three ways. We can use a chiral catalyst out of one that is the most effective way, using a chiral catalyst. Now, part F. Complete table 8.1 describe the peak seen in proton and NMR spectrum of this dissolved in D2. So if it D2 is there, so this and this hydrogen is, and these hydrogen are going to be removed. So you are going to get the peak of CH2 and CH, this and this only, because the NH and OH are displaced by D, those H, and D doesn't give a signal. Use as many rows in table 8.1. We need to leaving the other rows blank. Okay. So one due to CH2 and one due to CH has one hydrogen on the neighboring carbon. So N plus one doublet, and the neighboring for H, the neighboring carbon to which this hydrogen is bonded has two hydrogens. So 2 plus 1 is triplet. So one hydrogen on neighbor carbon, two hydrogen on neighbor carbon. Now, proline is a naturally occurring amino acid. The skeletal formula of proline is shown. State the number of peaks in carbon 13. So in carbon 13 means the different number of carbon atoms, the different types of carbon atoms are there. You are going to get these number of peaks. So this carbon is going to be completely different than the rest of one. Then this one is again because one side is CH2 and the other side is NH. This one is going to be completely different. Then this one, and then this one. We have a 5 carbon atoms, and each carbon atom is chemically different than the rest because of their adjoining and then their further adjoining carbons. Is this clear? Now, glutamic acid is naturally occurring amino acid. The skeletal formula of glutamic acid is shown. The isoelectric point of glutamic acid is pH 3. Okay. So lower than 3, it's highly acidic, and higher than 3, it's OH, basic alkaline. A sample of glutamic acid is dissolved in a solution of pH 1. A strong alkali is then added until the pH of mixture reaches to pH 14. During this process, all possible ionized forms of glutamic acid are present at different times depending upon the pH of the solution. Complete the boxes below to show the 4 different ionized forms of glutamic acid that are present at the stated values. Okay. So if you see at pH 3, it is going to act as a Zwitter ion. So this is going to be turned into NH3 positive. So that is at pH 3. So at pH 1, we have excess hydrogen ions, right? So the only place where there is a O negative that also accepts the hydrogen, and it is already NH3 positive. So that is how it behaves as at pH 1. So see, remember, the isoelectric point, make a Zwitter ion, lower pH, put all the negative O's with the H, higher pH, put loses the H. Now we have a pH 9 and pH 14. So at pH 9 is little alkaline, and pH 14 is going to be highly alkaline. So at pH 9, this was negative. See, it was NH3. So it loses the hydrogen to neutralize the alkali. So it would be like this. And at pH 14, the other carboxylic acid, which doesn't lose any hydrogen yet, also loses its hydrogen. So see, pH 3, Zwitter ion, positive and negative, both are there. Lower than this, excess hydrogens are there. So as a result, this O negative accept that excess hydrogen to form this. Little higher pH, more hydroxide. So this H positive loses the hydrogen to neutralize this, and we get NH2. pH 14, more and more, there are so many more hydroxides. So this OH, this both loses their hydrogen ions. Is this clear? Okay. So best of luck to all of you. Tomorrow I'll see, but whether I'll able to take the class, but I'm thinking that you guys can come up with your queries. So whatever the queries you have, you can WhatsApp me, you can share, send me, so I will give you the feedback on them. Or if you guys want, so we will have another class tomorrow as well. So tomorrow will be the last day. The day after tomorrow, you have a exam, right? So best of luck for that.